Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review what we did in week 6. So we just started looking at integration, which is the opposite of differentiation. When you're asked to integrate a function, you're being asked to find its antiderivative. So if I have the integral of like x to the power of n, I'm saying what function do I start with so that when I differentiate it, I end up with this. So here are a few formula that we went through. So if you want to integrate a power x to the power of something, you increase the power by 1, divide by the new power. So if you want to integrate e to the power of ax plus b, you leave the e and the power alone, but you need to divide by the derivative of the power here. And this is because we're just doing the opposite of what we do when we differentiate. If I were to differentiate something like this, e to the power of something, I leave the e and the power alone. When I differentiate, I would times by the derivative of the power, and the derivative of this is just a. So when I integrate, I do the opposite. I divide by the derivative of the power. So one that's a bit confusing is sine and cos. When you differentiate sine, you get cos. When you integrate sine, you get minus cos. And when you integrate cos, you get positive sine. So just be aware that you're not tripped up with the positive and minus signs. So again, when we're integrating sine of something or cos of something, we're just doing the opposite that we would do when we're differentiating. So let's put this together and do an example here. So here we have the integral of quite a few terms. So when you differentiate heaps of terms, you just differentiate the terms one by one. And the same is true when you're integrating. We're just going to integrate each term one by one. So in this question, this is like our f dash x. This is like our derivative. And we're saying, what function do I start with so that when I differentiate, I get this? So I'm just going to integrate, find the antiderivative of each term one by one. So for 2x cubed, I'm using this rule here. What you do is you increase the power by 1 and divide by the new power. That's how we integrate a power. So the integral of sine is minus cos. So the integral of negative sine would be positive cos. When we're differentiating or integrating sines and coses, the thing in the brackets does not change. So it's still cos of x over 3. So if I were differentiating this, I would times by a third, or I would divide by 3. So when I'm integrating, I'm going to times by 3. So this is the integral of that, because if I differentiate this, I get that. So integral of e to the minus 2x, we're going to use that one here. So we keep the e and the power the same, but instead of timesing by the derivative of the power, which is minus 2, I'm going to divide by the power. So I'm going to divide by minus 2. Now this gets a bit confusing. When you differentiate, constants like 3 vanish. The derivative of 3 is 0, but the integral of 3 is not 0. The integral of 3 is 3x. We're actually using this rule here. So when you differentiate 3x, you get 3. Now, when you're integrating, you need to put a plus c at the end, because it wouldn't matter what the constant was. This constant could be 1, 2, 3, 4. If I differentiate this function, regardless of what the constant is, I would get this. Now, sometimes, not all the time, but sometimes you'll be given an initial condition like this that will allow you to find c. So if this is like f dash x, then the integral is my original function, which is f of x. So to find what c is, I'm just going to substitute f of x for 1 and x for 0. So I get fx, which is 1, equals, so this would be 0. So this here, cos of 0 is actually 1. So this term here would be 3 times 1, which is 3. So e to the power of 0, if x is 0, this would be 1, so the whole thing becomes minus a half. Of course, if x equals 0, this would just be 0, and then we still have our plus c. So we can solve this equation really simply. It would give us c is equal to minus 1.5. So then this, our original function, I'm just going to replace c with minus 1.5. And there we have it. If I graphed this curve, it would pass through the point 0, 1. And if I differentiate this function, I would end up with that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.